We're in Algebra II at 10.1a. It's a new chapter, and this is going to be about the distance formula and any 2 points on a plane, and I have a theorem for you. So the distance formula can be used to find the distance between 2 points when we know the coordinates of those points. So here's our theorem. The distance between any 2 points, x sub 1 and y sub 1, and x sub 2 and y sub 2 is given by this formula. And this d stands for the distance, and you take the second x value and subtract the first one and square it. You take the second y value, subtract the first one and square it, and you add these together, and that's going to be the distance between any 2 points. So these little numbers are subscripts labeling the second value and the first value, so we could tell them apart. If we just saw this with the 3, 4, and the 5, 6, we wouldn't know how to follow the formula, so they tell us, okay, well, that's the first x, that's the second x, so that's got a sub 1, that's got a sub 2, see? So we know we need to do 5 minus 3, see? And then we would square that. So we can prove this theorem for the case where the points are not on a horizontal or vertical line. So our points are going to be this pink line right here, this D. We consider any 2 points. We've got x sub 1 and y sub 1, and x sub 2 and y sub 2. So if you look, here's the first x and the first y. Here's the second x and the second y. That's for the first point, and that's for the second point. So this one is on a 2 and a 2. 2 for x, 2 for y. This one is at a 10 for x and an 8 for y. See that? This last point that we're not dealing with is x sub 2, y sub 1. So it shares from each of these points some information. So we went from a 2, 2 to a 10, 8, now to a 10, 2. See? Takes the second x and the first y. So we're going to be dealing with these 2 points. This is our first point. This is our second point. And as long as this first x is not equal to the second x, because we would get a 0, wouldn't we? If our second x point was at the same spot, we wouldn't even have a line, would we? It would be on top of each other. And the first y can't be the same value as the second y. And these points are vertices of a right triangle. See? It's a vertex. That's a vertex. It's a corner. And then there's our other vertex, the x sub 2, y sub 1. Now the legs of the triangle have lengths. So here's a leg, and here's a leg. And this length is the x2 minus x1, and this is the y2 minus y1. See that? And we can say it's the absolute value of those, because it doesn't matter if it's negative and down here, right? If it was down here, we'd have negative for the y, wouldn't we? But it would still be that length. It would still be that many squares. Well, since squares of numbers are never negative, we don't need those absolute value bars. We can just put in parentheses. Then finding the principal square root, we end up with a radical sign on top of it. See? We subtract the x values from each other and square it. We subtract the y values from each other and square it. We add the answers to those squares together, and that's going to be our distance. So let's try this. Now, what I also want to point out is sometimes you're going to see this formula, and it might have x1, x2, y1, y2. It doesn't matter. You're still subtracting one x value from the other, okay? So you're all right. Most teachers have x2, x1, okay? And y2, y1. All right, we can find the distance between the points. X is 3, y is a negative 5, and x is 8, y is a 7. So we substitute these coordinates into the distance formula. So this is our first x, isn't it? That's our second x. So we're going to do 8, take away 3, and it's squared. Here's our first y. Here's our second y. So we're going to have 7 minus a negative 5. And when we subtract a negative 5, we're going to add the opposite, aren't we? So we're going to do 7 plus 5, and then that's squared. So now we have 5 squared plus 12 squared. That's 25 plus 144. and that's 169. And the square of 169 is 13. So the distance would be 13 between the 2 points. Let's check out this one. This one's a little bit harder, but you should know how to do this by now. We're going to find the distance between x is a negative 3, y is a negative 3, and x is a 3, and y is a 3. So we do 3 minus a negative 3. That means we're going to add the opposite, isn't it? So we're going to get a 6, and we need to square it. And then this is going to be the same thing. We're going to add the opposite and get a 6, and it needs to be squared. So we have 36 plus 36, don't we? We can factor this as 36 times 2, because there's 2 of them, right? Which is a 72, which is 6 times 6 times 2. So we can pull one of these 6's out in front of the radical sign and leave the 2 inside, and we've got 6 square root of 2. See how I did that? Sometimes people have trouble figuring out how to do this. That's why I figured I'd spell it all out, all right? So that's the distance between these 2 points. It's 6 times the square root of 2, okay? Now, we're going to get into the midpoint formula in our next video. We're going to talk about midpoints of segments in 10.1b. There should be a B there. I'm going to add this to the Algebra II playlist. We don't have any previous videos for Chapter 10 yet, okay? So I might still have some stuff in the description that you can click on, like a link to the Algebra II playlist and Algebra I playlist, stuff like that, okay? So I hope this was helpful. I hope you're having a great day. Keep trying. We're making it. We're at Chapter 10 now. We're almost through. Bye.